Day 2 of SubOptic 2019 began with the opening ceremony, emceed by Stuart Barnes. After welcoming attendees, he introduces Yves Ruggieri, who officially opened the conference as president of the SubOptic Association.
I now declare open SubOptic 2019 and wish you a very good event.
He was followed by remarks by Kimberly LeGroux, Chief Information Officer of the City of New Orleans, who welcomed the submarine telecoms industry to her city. The keynote speaker was introduced by Ian Clark of Ciena, this year's host company. Gary Smith, President and CEO of Ciena, gave a forward-looking speech on the digital revolution and its ongoing impact of the submarine telecoms industry and the world at large.
You know, our common bond is that we've provided the fundamental underpinning or the infrastructure to enable the digital revolution. But I'd encourage us to think a little broader around that, because every day we're in it, every day we experience it. But I think it's good sometimes just to step back from the day-to-day and think about the broader context of the folks in this room, the industry that we represent, and what the contribution is in a much broader context. And particularly, the rate of change that this digital revolution is both enabling and in some cases forcing, and the challenges and opportunities that are being thrown up because of it.
Following the opening ceremony, the first oral presentation sessions of 2019 began. Topics for this year ranged from advancements in wet and dry plant technology to evolving market trends. Legal and regulatory hurdles were explored in one session, while diversity and inclusion was tackled in another. The rooms were once again near capacity, reaching well above 250 attendees in some cases. I'm here with Elaine Stafford from DRG, and she's going to be telling us a bit about her paper and her observations in mesh networking.
Hi, it's really nice to talk to you. I was just lucky enough to be able to present the paper that I worked on with my colleagues and together with Facebook. And really the paper was about meshes and where meshes are going, and will the density of meshes as the market demand grows and grows and more cables are built, will it mean that cables don't need to be repaired as quickly as before and that they can become unreliable, and that some of the things that I learned decades ago about the important things in undersea cables are decreasingly important? And the answer is, as far as I can see out there, you know, some of the fundamentals will stay the same. It's important to design and engineer robust cables, and it's important to have predictable repair service.
What main takeaways are you hoping that people have from your presentation?
I think that reliability continues to be fundamental in this industry. It's one of those first things that you learn when you join our industry, that reliability is critically important, and it's going to stay that way for quite some time. You know, the laws of large numbers that these visionaries at other conferences were saying will allow cables to become less reliable are way off in the future from my perspective, at least beyond my horizon. And so I think reliability will continue to be fundamental.
Do you see this trend taking us anywhere differently for the industry?
No, I don't really. I think what's really driving the industry is a complement of this and other things, and that's SDM. At the workshop yesterday, you had some wonderful speakers talking about SDM technology, higher fiber count cables. I think that will continue to support this same thesis, that as you put more and more capacity into individual cables, you've got to find creative ways to keep them engineered robustly. That means powering them from end to end, and it will be important to keep them up with all the demand that's traveling over them. So I think the technologies are going to continue to push the paradigm just like they always have, of putting more capacity in cables. The meshes might not grow as fast as some of us thought they might when we didn't see SDM on the horizon. And that means that it's important to keep each individual cable up and running as best as you can. That's it.
Elaine, thank you very much.
Thank you.
I'm here with Dr. Venkata Jasti, who's going to tell us a few of his observations on automation in both cable and system engineering. Mr. Jasti, can you tell us a bit about your paper?
Yeah, so the paper which we did jointly with Facebook, right, so it's taking a look at automating some of the things that we've been doing for a long time in the cable industry, right? So what we bring to the table is a control software that gets installed on cable laying vessels and helps them do like real-time guidance. So what we're trying to push the envelope is that how do we automate some of these tasks, right? So we understand the cable behavior already. We are already directing these cable laying installations, but how do we get towards the next step where we like automatically calculate what the vessel should do, what the cable engine should do, and how do we then directly push these things to cable engines and DP systems so that these things can automatically happen. Right? So that's the goal that we're trying to get to, and this paper was one step in that direction. So it was specifically talking about how do we automate like route engineering tasks and how do you automate like vessel navigation tasks. So these route engineers, they go through a series of things that they need to check when they're actually creating these submarine cable routes. And this tool is basically running continuously in the background and warning them if they missed any one of the important constraints. So they can't cross existing cables, they can't be closer to certain infrastructure. So as if they put those rules in, it's continuously checking and telling them, oh, when you're doing your route engineering, you're getting too close to something, watch out for it. The other tool was the vessel navigation one, which is saying you want to install the cable around alta courses. It takes a bit of an effort to understand how the vessel on the surface should maneuver. And this tool is going to come up with what those waypoints are automatically. So those are the two areas. But the larger goal is like how do we keep doing these things for various stages so that we get towards automation.
Right. So it's more than just route mapping as well. You also have an aspect that you can apply to the cable engineering itself?
Yes. So it's all steps of the submarine cable life cycle. So it starts with route engineering, and then you do a step where you do installation planning, where you're thinking about how do cable vessels go about handling these installations. And really important is the third part, which is real-time installation management, right? So when you are at sea and things are changing, how do you still keep your installation on track? Like how do you make sure that the vessel is still being guided properly so that your cable is getting installed correctly, right? So it could be things that you have done, like maybe your vessel turned wrong for a little bit. It could be changing currents. It could be emergency stops. There's all sorts of at-sea things that you don't anticipate. And during those episodes, are you still keeping your cable lay on track, right? So that's the question of real at-sea management.
So how do you see these application of this automation, these algorithms changing the industry in the long term?
I think the push has to come from cable owners, as always has happened, right? So the interesting thing about this SubOptics is that we have new people in the mix, right? So we see lots of name tags with Googles and Facebooks. If they push, I think it will happen. If they don't, we will see what happens. So I think that's the force. That's the force that has to, push the installers and push all the, subcontractors to these installers to innovate and, do newer things. So I think it has to come from the owners.
All right.
Yeah.
Well, thank you very much.
Thank you.
I'm here with Jan-Kristoffer of Alcatel, who is here to present a paper on a newer technology within the submarine telecoms industry. Jan, you want to tell us a little bit about this technology?
Yeah, it's called distributed acoustic sensing. It means that a continuous length of the fiber can be used as a sensor in addition to being a communication channel. In this way, we can sense any harm or aggression to the cable and protect it in that way.
Would this technology require any sort of additional changes to existing projects?
In principle, the cable can be the same, but we will add a sensor interrogator at the terminal equipment.
Do you see this being a very positive addition to systems? Do you see something that's going to be growing in the market?
Sure. For protection of cables and also for sensing of the environment outside of the cable.
All right, thank you very much, Jan. I'm here with Nigel Bayliff, CEO of Aqua, and a participant in today's Leaders Debate with a theme focusing on market trends. Nigel, you want to tell us a little bit about that?
Yeah, we had we had a great debate. We had the vendor community represented. We had the operator community. I'm a carrier operator. We had carrier who focuses mainly on African continent. We had representative of one of the big consultancies, and then we had one of the members of the Facebook team that are deploying cables around the world, Ricardo Ocero.
What kind of conclusions did you come to in this debate?
Well, I mean, the themes were really about what have we seen in a change from last SubOptic to this SubOptic. The last SubOptic 2016 was in Dubai, and back then the ICPs, the big internet content parties, were just entering the build market. They were just probably signed their first big build project. Now they're in 7 or 8 and 9 different build projects and with plans for many more. That, to me, wasn't a surprise. I think our industry has always been characterized by people who have a huge need for data or for carriage of information across the oceans, have always been the parties stimulating the growth and the decision about where to put a cable. Used to be carriers, because it used to be all around phone calls and text messages and various other things. And now it's more the big machine-to-machine communications between the data centers of the ICPs. The industry has some big change already baked into it for the last two or three SubOptics, so the last 10 years roughly. But going forward, really one of the big things that we finished with and I concluded on was that whatever we think the forecast is now, it's probably wrong. And frankly, it's always been wrong. So I've been in this business for 30 years and I've never seen the forecast be right. Sometimes it's been wildly right one way or wildly right the other way, you know, and we've had periods of that swing. We get better at predicting how wrong it might be and in which direction. But frankly, this is a take it as you go industry, because we don't know as individuals what the next app or the next feature that will come out, which will drive massive data requirements across oceans. So we've got an industry which has got a 20, 30 year kind of viewpoint where the capacity requirements are changing on a 1 or 3 year time period, right? So there's an interesting complexity to how you manage the risk. And it's a big challenge, but this organisation, SubOptic, is interesting. It brings people together focused very specifically on this one piece of the industry that not many people in the world know about. And I see in the audience always faces for people I've known and worked with for 30 years. Almost certainly we're not in the same company we were 30 years ago, 10 years ago, even 3 years ago, because there's recycling is the wrong word because it sounds like you're just moving things around, but there's a body of knowledge that's available in this community that gets put to play in different ways. And now it's the ICPs, Facebook, Google, Microsoft, all those guys have got people with long histories in the industry trying to understand how to take their company forward now. But as a body, as a SubOptic group, actually we've got some big things to fix for the world. You cannot go forward as a society without these things, and we have to try and do these things in an efficient way. It's as big a challenge as, okay, maybe not climate change, but it's that sort of idea. There are people in the world that don't have access to the internet still. Most of us couldn't even contemplate that.
But in companies using this body of knowledge, you see greater specialization down the line?
Yes, exactly. And I think people will aggregate together for very specialist reasons, and you'll almost have a group approach to doing things, as opposed to now we try and integrate things and capture all of the margin is usually the way we try and look at it. But actually we'll say, no, we're going to take slices because it's about being the best or certainly close to the best to be able to survive, not just to thrive, but to be able to survive. Because it's very easy to not make money in this kind of market.
So taking it for granted that any forecast is probably not going to be spot on, but if you were to take a guess at 2022 and what you would be talking about in the leader debate at that point, what do you see talking?
Well, we'd certainly be talking about bigger cables than we've ever thought of before, with more fibre pairs, with more capacity per fibre pair, but maybe greater granularity, so cables which mesh out on the ends to lots of remote locations to try and draw some of these unserved areas into the World Wide Web of communications. And I think we'll still see the same debate of, if we don't know with surety what our 20-year requirements are, how are we going to start financing building new ships or building new factories? You can't just turn on a ship and turn off a ship. It's a $150 million decision. So, we'll still be talking about that, but then we've been talking about that for probably close on 20 years. So.
All right. Well, Nigel, thank you very much.
No, thanks very much.
I'm here with Fatih Yaman from NEC, and he's going to tell us a little bit about his paper, which he presented today, on neural networking as applied to the submarine telecoms industry. Fatih, can you tell us a little bit about that?
Yeah, sure. In submarine communication, we are dealing with several problems that come from the fiber, and we use DSP to remove these problems. And one of the traditional methods is we know how these problems are produced in the fiber, and then we undo that problem. And then what we call that technique is it's like a deterministic way of doing it, because we know how it occurs, and we just do the reverse. But now what we are trying to do is something a little different, which is we try to solve this problem as if we don't know how this problem occurred. We just put it in a black box, and now we ask the machine learning algorithm to figure out this mechanism just by itself just from the data. So it receives the data, and from the data itself, it figures out this mechanism and then solves this problem. And so we see that there are several advantages to that, which one of them is that when we apply this kind of DSP, it doesn't know where we are applying it, what kind of system. It just determines it from the data itself. And the other advantage we found out is that it reduces the complexity of implementation. So compared to the traditional methods, it requires less resources, so it becomes easier to implement. So that's why we are working on this.
So why would it reduce complexity?
It seems to be reducing the complexity because when we use the deterministic methods, some of those components we are using may not be actually contributing much, or several of those components may be containing information that are also shared by fewer components somewhere else, and then it becomes very difficult to figure those out, and we don't actually need to think about that, and then machine learning can go and figure out all these. It can reduce like all these complexities and figure out while removing some pieces. It can retain the most important parts, so it can still work well while using less input.
What kind of success have you seen with this method so far?
We see, depends on the application case. So in terms of complexity, depending on the improvement, we see roughly 40 to 50% reduction in terms of the complexity required for the same level of improvement. So, but that is for the region where the resources are very low. If we have a lot of DSP resources available to us, it turns out that the traditional methods and our method kind of even out. But in the more practical case, where the DSP resources are limited, it seems that our method is more effective. Maybe like we see, depending on the condition, single channel or WDM or the WDM spacing, it's 40 to 50%.
And how do you see this implemented in the future? Do you see this being a growing method?
We see machine learning algorithms become more and more investigated for many different kind of applications. So in our particular case, we looked at applying it to nonlinear compensation, and it is still very resource hungry. And so in that sense, it may not be applied very soon. And another reason is actually in terms of ASIC development and DSP development, we have, like, the industry has a lot of experience with the traditional techniques, and these machine learning algorithms are kind of new. So we feel it will take a few cycles for engineers to get more comfortable with it and then optimize it for it to be implemented.
Well, Fatih, thank you very much.
Okay, thank you so much.
I'm here with Anjali Sugadev, who is at SubOptic 2019 presenting her paper on the unique challenges presented in the growing market in the Arctic. Anjali, you want to tell us a little bit about that?
Yes. So my paper talks about the Arctic cables and the already planned and upcoming new projects that are going to be laid in the Arctic region. So I'll talk a bit about the international law that governs the cables laid in this region, and also the specific national legislation that regulates the cable activities. And I'll also be elaborating a bit about the Polar Code and leave you with some concluding remarks.
Okay. What kind of legal challenges do you run into in the Arctic that you don't see in other areas?
I think the international law is not very clear. It's a bit ambiguous and gives room for interpretation by the coastal states, by the circumpolar states to be specific. So these national laws actually have sprung out of and have got legal validity from these uncertain laws of UNCLOS. So I think that's the biggest challenge for the cables that are going to run in the Arctic.
Do you see other areas and industries where these kind of challenges present themselves?
I think not as much for other industries because they have already established themselves and there are specific guidelines and these guidelines are industry specific, like for oil and gas. But for cables, it's a very upcoming and new activity. So I think it's a big challenge to address it with the existing regime, or maybe we'll have to establish more best practices and some sort of uniform guidelines for cable operations.
All right, thank you very much. Now, Anjali, you also had a bit of a unique way of arriving at SubOptic 2019,
Yes.
correct?
Yes, I should really mention that I got this travel support and registration fee waiver by SubOptic, and I really appreciate this gesture by SubOptic for encouraging young talents and for supporting me to come all the way from India to the US and make my presentation in front of this very elite gathering. Yeah, thank you SubOptic, and thank you for all those sponsors who made this happen.
And how did you hear about SubOptic? How did you think to look into coming?
I've been hearing about it for quite some years now, and especially when the last SubOptic happened in Dubai. But this year it actually started when I got in touch with the legal advisor to ICPC, Mr. Kent Bressy, and he suggested that, okay, I said I want to get into the cable industry and contribute my knowledge and my legal expertise to it. So how do I do that? And then he suggested, why don't you submit an abstract to the upcoming SubOptic happening next year? So last September I applied for the abstract with my abstract, and I'm here. So that's how it happened.
Great. And now that you've had a chance to dive into it and you've done your presentation, what do you think about SubOptic?
It's amazing. It's a big and huge platform for a youngster, a young professional like me in this industry, and I get to network with people. I get to meet a lot of companies, firms, people from different backgrounds and cultures, and especially be here in a very vibrant city like New Orleans. Yeah.
Anjali, thank you very much.
Yeah. Thank you very much.
I'm here with Mark Fortin of SubCom, the co-chair of the papers being presented at this year's SubOptic. Mark, can you tell us a little bit about the papers this year?
Yes, we had a very good turnout. We started with 155 submissions at the call for papers, and we ended up with 139. The quality is exceptional, and I think also all the poster papers have the equal quality than the oral presentations. So it's very important for the people here to make sure that they access these papers, the one that are for the posters, because we were limited for the oral presentations to to 95. So this is why we had to have some posters allocated for the papers. But the quality is outstanding.
Is there anything you're seeing about the subject of the papers that's kind of unique to this year?
Yes, this year, I think 2019 is going to be a year of SDM, a year of 18 kV in the industry. 2018 was open cable, which is completed now, where the standards are defined. It's not adopted by the ITU, but we see that everybody's moving to something else. So SDM and 18 kV and aluminum cable for 2019.
What are you hoping that viewers come away with after the paper reception this evening?
A lot of new relationship, a lot of contacts, and a lot of updates in the industry. So SubOptic, I think, is a unique conference. It allows the people to have an update on all the aspects of the industry. So it's just not like side meetings for business, but it's really people are attending to the session. So this is very important. So they will go back home with an improved knowledge in the industry.
Thank you very much.
Thank you.
The day ended with the poster reception, which featured 48 papers covering a wide range of academic, commercial, and technical topics. Visitors spent the evening perusing the displays while discussing the newest research of the industry. This is Nigel Irvine with Deep Blue Cable. He is presenting, one of our presenters, with the poster reception.
Yep.
If you want to tell us a little bit about your paper.
Yeah. So this is a poster presenting the results of the marine survey we did between St Vincent and Grenada in the Grenadines and the Grenadine Islands. And this is for a project for Digicel, who is our parent company. And this is a project that's funded by the World Bank and the governments of St Lucia, St Vincent and Grenada. And the poster shows how the survey data radically demonstrated different bathymetry to what was shown on the existing charts and on Google Earth, demonstrating the need for proper marine surveys.
And right now you're seeing a trend towards using those kind of resources instead of a proper survey?
Well, there has been some talk in the industry that you don't need to do a full survey because you can rely on existing imagery on Google Earth. This is trying to portray the fact that in many areas of the world where you've got a paucity of submarine of bathymetric data, you still need to do a proper survey.
Can you give us an example of what you found that Google Earth did not?
Yeah, so here you see on Google Earth that there's a flat seabed, yeah? And what we found was a very heavily incised seabed, submarine canyons with a continental shelf edge had slumped and produced some fantastic imagery of that. This also then meant that we could not route the cable across this area of seabed because it was so steep, incised, volcanic seabed. So we had to then do another survey on the top of the continental shelf. We also did surveys on the shallow water survey of all the islands, which produced some fantastic imagery of the seabed in the shallow water, coral reefs and sand waves, etc. So all in all, it helped us determine the appropriate cable route and make appropriate decisions as it relates to route engineering and the permitting process. And importantly, because it's a World Bank project, the content to the environmental and social impact assessment, which the World Bank required to be undertaken.
All right, well, thank you very much, Nigel.
Thank you.
Yeah. All right, we have with us Andrée, one of our presenters for the poster reception. Andrée, you want to tell us a little bit about your paper?
Yes, absolutely. So we're presenting here a tool that we offer to customers that is based on big data and machine learning to enable them to do proactive maintenance on their networks. So in this particular case, we've been working with Southern Cross as our partner to use that model also on submarine equipment, and that's why we're here today. So basically, we have been experimenting that our models can work very well using that submarine data. So, for example, if you look at this plot over here, this is how it would work in a terrestrial equipment where we have much more regular daily data. This is how we detect when a problem is going to occur. In the case of submarine, as you see on the main plot, this is a detection of patterns that we see in the data that is unusual, so we could flag it to the customer. Of course, proactive maintenance under the sea is a totally different story. It's not as accessible as a terrestrial equipment. So in this case, it's more an indication of the degradation or aging of a cable, and then it's up to the customer to decide what they want to do in the future to take as proactive maintenance decisions or measures. We're here basically to provide them with the information, and not only just the trending, but it's mostly or the graph, but it's mostly giving them access to a ranking of their risky equipment, so that they can focus on what's important and leave the equipment that works well do its own thing.
What would you say is the most commonly found problem when you're looking at these analytics?
You mean most common problems on networks or of the algorithm on its own?
No. What issues does the algorithm most often find?
Yeah, often actually it's really network health is a really good name in that sense, because it's really basic network health assessments that has been the most prevalent issues. Mostly fiber cleaning, fiber bending, fiber degradation that eventually incur the network element to misbehave, to have funky measurements, and to degrade over time. And that's in the terrestrial world. In the submarine world, we're just, as I say, we're not like, we cannot go and act on the repeater. So we've been less able to really act upon those things. But that's really our experience from the terrestrial side of things.
All right, well, Andrée, thank you very much.
My pleasure. Thank you so much for the interview.
I'm here with Maftei, who is one of our presenters for our poster reception. Jan, if you want to tell us a little bit about your poster?
Yeah. Hi. So my poster is about band limiter. bend limiter is an element used to limit the bending angle of repeaters when they get deployed. And the product we have on this poster is a product we're going to use in the next generation of repeaters. It's designed for lightweight cables, lightweight and lightweight protected. It's designed. The most important reason behind the design was to reduce some cost. The current bend limiter we use is made in titanium, and it serves the whole range of cables, starting from lightweight to double armor. The load requirement for lightweight, it's very different from that to the armored cables. And because of that, we wanted to create a product that's suitable for lightweight, that would accept a lower load, but it will give us an important reduction in cost. And because when we talk about a long-range system, a lot of the repeaters will come in deep water and will be installed with using lightweight cable. This will give us a significant cost reduction.
What challenges have you found with trying to change out to these kind of composite materials and newer material options?
Right. Well, the first challenge was to try and find a suitable composite material. We ended up using carbon fiber, but we didn't know it was going to be carbon to start with. So we tried a couple of options, and we made contact with some composite suppliers and tried to understand the advantages and challenges of some other composite materials in regards to cost, availability, and also our technical requirements. We ended up using carbon fiber because it proved to be the optimum solution for our application. Then some other challenges were to try to work with the manufacturers so that they would come up with a process that would be customized for this application. Some particular challenges were in regard to wall thickness. This product uses a relatively thick wall for this kind of material. Some other challenges were in regards to the geometry of the part. The current bend limiter we have in titanium uses some intricate geometry, and when we wanted to transfer that into composite, a lot of those elements of geometry were either hard to machine or to manufacture, or unpractical. So we had to rethink the geometry and the way it worked in a way that it became a bit more simple, more robust, and suitable to be manufactured in composites.
And you've seen success with your finished products?
We did. We went through the whole development process from concept to CAD design to prototyping, initial testing of the prototyping, mechanical testing, and many other testing. And then we've done a whole bend limiter. We put them together and we tested them for the load of the cables and for in the test yard to simulate the deployment conditions. The picture in there shows a test around the sheave, and the product performed well under the whole range of testing. And we are getting close to the point where we are actually able to deploy this in a submarine system.
Well, Jan, thank you very much. Yeah. The attendees continued through the conclusion of day 2, learning and enjoying in this unique time spent in New Orleans.